All right, small changes, part one. Small changes. What do we mean by small changes? If two values are related, if two variables are related, not any two values, like y and x, right? There is a relation between y and x. Any small change in one of them, it reflects with this small change in the other, right? If change in one variable, x, for example, let's say delta x is change in x, right? Change in variable x, change in variable x, resulting the change in the other variable, which is y. Delta y is change in y. Any change in x results a change in y. Uh, how can we estimate this change? We use the derivative of y with respect to x. We use the derivative of y with respect to x. What's the meaning of delta y? Delta y, it's the second value, right? It's second value of y minus the first value of y. If y, it will be either negative or positive. Here represents if the value increased or decreased, right? What is that equals to? Simply, this means delta y is equal to y of x plus the increase in x, right? Minus the y of x. Suppose y is related to x in the relation y of x. If x is increased by delta x, this means the new value will be y of x plus delta x. All right, and the derivative, we know the derivative is dy divided by the x, right? Divided by the x, and that will be equal the limit as h tends to 0 of what? Of y of the second value, which is x plus delta x, minus y of x, right? Y of x over delta x. Okay, that is equal to, let's say, it's equal to, let me continue here, it's equal to the limit as delta x tends to 0, as delta x tends to 0 of delta y over delta x, right? Where h is the small increase in x, right? So delta x, that y over delta x, it's approximately equal delta y over delta x, right? It's approximately equal delta y over delta x. In other words, delta y, if dy over dx is the change in y as change of x, if it is delta y over delta x, this means that that formula we are going to use now, delta y cross product, right, is equal to dy dx multiplied by delta x, right, by multiplying delta x both sides. So this formula is related to delta y delta x and dy dx. Okay, this formula we are going to do. Let's see an example. If we have, for example, uh, example says using the derivative of the volume of a sphere with respect to its radius, estimate the change in the volume of the balloon, which is the sphere balloon, as its radius increases from 5 to 5.1, from 5 centimeter to 5.1 centimeter. We all know if the balloon increased, the radius of the balloon increased from 5 centimeter to 5.1 centimeter, this means the volume will increase, right? Let's see how much the volume will increase. What is the volume of the balloon or volume of sphere? The volume of the balloon or sphere is 4 over 3 pi r cube. A small change delta r, because the increase in r is how much? The increase in r, delta r is equal to 5.1 centimeter minus 5 centimeter. This small change, which is 0.1 centimeter in radius, induces a change in the volume delta v, right? In change of the volume of delta v, right? We call it, where delta v is what? Delta v is, according to this formula over here, delta v is equal to the derivative, right, dv to the r multiplied with the change in R. Multiplied with the change in R. Now, what is delta V over delta R? Delta V to dV, I mean, to the R is equal derivative of 4 over 3 pi R cube to the R, right? 4 over 3 pi is a constant number. Take it outside. What is the derivative of R cube? It's 3R squared. 3R squared. For sure, we should multiply with dr and all of that over dr. And this is 1 because I'm deriving with respect to dr. So the final answer will be 4 pi R squared. All right. What is R now? First, let's see. This delta V to the R is equal. This delta V to the R, let me go back up to here. This delta V to the R I'm finding, it's 4 pi R squared multiplied with delta R, right? What is 4 pi R squared? It's 4 pi. What is the radius? What was the radius before increasing? Was 5 to the power 2 R squared times delta R, which is 0.1. Now we multiply these values. 5 squared, it's 25. 25 times 4 is 100. 100 times 0.1, it's 1. It's 10, sorry. And pi is 3.14. 3.14 times 10, it's 31.4 centimeter cube. This is the increase in volume. In case the radius increased by 0.1 centimeter, the volume will be increased by 31.4 centimeter cube. Another example. Let's do another example if we have time. If we don't, I'll continue in the other video. The length of a rectangle area. This is nice. We have a rectangle. The length of the rectangular area is 10. The length of rectangle of area 10. Let's say area of rectangle is 10 meters square, right? The length of this increases from 4 to length increases from 4, so delta L increases from 4 meters to 4.1 meters. So the increase is 0.1 meters. We want to estimate the change in the width. Means I need to find the delta width. That's nice. What is the relation between length and width? Area equal length times width, right? Area equal length times width of a rectangle. So can we form, which is equal to 10. This is a relation between length and width. We have to start from here. We need the change of width. So if we need change of width, let us find the width. If length times width is 10, this means width is 10 divided by the length. Let's differentiate both sides in terms of length. So dw to the length, right, is equal, change of w to change to length is equal to d of 10 over L, right? That means dw over dl is equal to minus 10 over L square. You know, the derivative of 10 over L is 10 times the derivative of 1 over L, right? What is the derivative of 1 over L? We can find it as u over v, or we can make the reciprocal to write 1 over L as L to the power minus 1. It will be minus L to the power minus 2, or minus 1 over L square, right? Now, what is delta L? Delta L, we found it already, and it is 0.1, right? This is delta L, 0.1 meter. This is delta L. And what is delta W? According to our rule up, delta W will be equal to dy to the over the L times delta L, right? What is dy over the L? We have it, and this is approximation, right? All of this is approximation. It's not exactly equal. Dy to the L is minus 10 divided by length square of the rectangle multiplied with delta L, which is, we have it as 0.1. Do we have the length? Yes, it was 4 meters before increased to 4.1. This means minus 10 over 4 square, which is 16, let's say, times 0.1, and this value will be equal to minus 1 over 16, and it's negative, so it's 0.1. minus 0.0625 meters, and it's decreased by 0.